All right, solving with quantities. What does that mean? Well, it's easier than you might think. Solving with quantities is a fancy way of saying solving with parentheses, which means the distribution property. So solving with quantities. This is a quantity. Some people might say this, and if I said, read this problem out loud, most people would say 2 times x plus 3, and that would be wrong. You do not read this as 2 times x plus 3. This is 2 times x plus 3. This is actually 2 times x plus 6, but that's not how you would read it either. So if you say this is 2 times x plus 3, this is what you're telling me. I'm thinking that you're reading this. Like, say I can't see your paper, and I say, read to me what's on your paper. If you say 2 times x plus 3, I'm going to think this is on your paper, but that's not what's on your paper. This is. So don't say 2 times x plus 3. What you say is 2 times the quantity of x plus 3. All right, that's technically how you read this. 2 times the quantity x plus 3. So when I say solving with quantities, I'm talking about parentheses. The parenthesis is a quantity. All right, and you would actually solve this by distributing the 2 through everything inside your parentheses. And you'd say 2x plus 6. And now you can see that 2x plus 6 is different than 2 times 2x plus 3. That's why you don't read this as 2 times x plus 3. All right, that's just a little vocabulary and how you read math. But how do you actually go about solving these? Let's say you had 8 is equal to the same thing I just did, 2 times the quantity x plus 3. Well, there's 2 different ways to go about solving this. You can distribute first and then start moving numbers over to the left to get x by itself, or you can move that 2 over there first. All right, think about it like this. Different problem. Say it was 2 times or 8 equals 2x. What would you do? You would divide 2 to the other side. All right, and you would say 4 is equal to x. That would be a simple problem. Everybody can do that. X is equal 4 in this problem. Well, this is very similar to that problem. This 2 is essentially a coefficient of that quantity. And when you're multiplying a coefficient times a variable, you divide that coefficient to the other side. So this is saying double this quantity and it'll equal 8. So what do you have to double to equal 8? You have to double 4. So this whole quantity needs to equal 4, because if we multiply 2 times 4, we get 8. So how did we know that 4 was the magic number, that this quantity had to equal 4? We divided 2 to the other side. Divide by 2, and you get 4 is equal to x plus 3. So this whole quantity, x plus 3, needs to equal 4. So what do we add 3 to make it equal 4? We add 3 to 1. 1 plus 3 equals 4. And if this was too complicated to do in your head, you would get 3 to the other side, work backwards, subtract 3, and you'd have x equals 1. So x equals 1 in this problem. All right, the other way to do this to end up with x equals 1 is, instead of dividing by 2 first, you can distribute the 2 first. And you could say x is equal to 8 is equal to 2 times x, which is 2x, plus 2 times 3, which is 6. So now we're saying some quantity plus 6, this term plus 6 is equal to 8. What plus 6 equals 8? 2. We know that 2 plus 6 equals 8. So this whole term needs to equal 2. All right, if you don't like thinking that through in your head, you just follow the steps. You move 6 to the other side. We were adding 6. We went across the equal sign, so now we got to subtract 6. 8 minus 6 is 2. 2 equals 2x. So 2 times what equals 2? 2 times 1 equals 2. How do we show that on paper? We divide 2 to the other side. 2 divided by 2 is 1. So we still end up with x equals 1. So you can distribute first, turn it into a 2-step equation, subtract 6, divide by 2. Or you could divide by the coefficient of that quantity, get 8, and then get 4, and then subtract the 3 and get 1, like I did the first time. So 2 different ways to do that. You can distribute and then start solving for x, or you can move that first. Well, this is when it gets a little bit more complicated here, is when you have a variable on each side of the equation. So let's say you have something that looks like this. Let's say you have 3 times x minus 2 is equal to, let's say, 2 times x plus 5 plus x. All right, when you get something that looks more complicated like this, you have x's on each side of the equation, you have quantities inside parentheses on each side of the equation. Now, you're not going to want to start by dividing 2 to the other side or dividing 3 to the other side. The only way to really do this now is to get rid of these parentheses. So normally in the past, I've always taught this by get rid of your parentheses first. I know I just showed you on this last example that you don't necessarily have to get rid of your parentheses first, that you could divide 2 to the other side first. When I say get rid of your parentheses, I mean distribute. So distribute the 3 and distribute the 2. All right, normally that is the best way to do the problem. All right, if you get something that's real simple, you don't necessarily have to distribute. You can divide by 2, but that's just for the easy problems. When they start getting more difficult like this, you have to distribute first. So it's probably a good idea to get in the habit of distributing first, even on the simple problems, because you're going to have to do it on the harder ones anyway, so you might as well build that habit. So let's distribute this first to get rid of these parentheses. So this will be 3x minus 6. This will be 2x plus 10 plus x. Don't turn that into a 2x. That's a mistake I see sometimes. People want to multiply this 2 by all 3 of those. You only multiply the 2 by what's inside the parentheses, not by that one. That's a separate term. Separated by a plus sign, it's a separate term. That 2 does not go with that x. All right, now we can start combining our x's together. So the 2x and the x are on the same side of the equal sign. They're both on the right. We can combine those like terms together. A positive 2x and a positive 1x is 3x. So you get 3x minus 6 is equal to 3x plus 10. All right, and this is going to get into a situation where there's no solution, and that comes later in the year, which is a little bit more complicated. So I'm just going to switch this up a little bit here. Sorry about that. Call this 4x, just so that we don't run into something that you don't need to know yet. All right, so it's 6x on this side. There, 2 times x is 2x, 2 times 5 is 10. We had a 4x here. You combine their like terms, you end up with 6x. All right, now we're back to what we did yesterday. You have a variable on each side of the equal sign. You got to combine those together. Don't make them 9x. I know this is a positive 6x, and this is a positive 3x, so you might say those come together to make 9x, just like these two positives came together to make 6x. The difference is these are on the same side of the equal sign. That's why they make 6x. You can combine them together without changing anything when they're on the same side of the equal sign. When they're on opposite sides and you combine them together, you got to switch one of the signs because now we're working backwards. When you go to the other side of the equal sign, we're working backwards. We're trying to solve the mystery by working backwards. So which one are we going to move, the 3x or the 6x? That's right, the smaller one. You always want to move the smaller one. So subtract 3x to the right. And what we have on the left now is just a negative 6. 6 minus 3 is 3, so you have 3x plus 10. Okay, now we want to get the x by itself. That means we got to get the 10 and the 3 to the other side, and then we'll have x by itself, and we'll know what the mystery number is. So some term plus 10 equals negative 6. That's a little bit difficult to figure out in your head. It's actually negative 16. If this whole term was negative 16, then negative 16 plus 10 is negative 6. So this whole 3x needs to equal negative 16. Well, if you don't do that in your head, you follow the steps and you move 10 to the other side. It was plus 10, now it's minus 10. So you have negative 6 minus 10. You're $6 in debt minus another $10. Now you're $16 in debt. You're at negative 16. So negative 16 is equal to 3x, just like I was saying when we were trying to figure it out in our head. This whole term needs to equal negative 16 because negative 16 plus 10 is negative 6. And that, in fact, we figured out by showing our work is correct. You subtract 10 to the other side, you get negative 16. Negative 16 is what 3x needs to equal. So then to solve for x, you just divide 3 to the other side. And when you divide negative 16 divided by 3, that's a fraction that doesn't reduce. So you could just leave your answer as negative 16 thirds. If you want to turn it into a decimal, that'd be negative 5.33333. But that's sufficient. You don't need to be turning your answers into decimals. You can just leave them as fractions that are fully reduced. So if that was, say, negative 18 over 3, you'd have to reduce it to negative 6. So you got to reduce your fractions, but you don't have to turn them into decimals if you don't want to.